All right, for our first video, we're going to go over solving linear equations. So solving means I'm going to look for the value of x that makes that equation true. Okay, but before we jump into solving, we're going to do a little bit of reviewing, some algebra stuff. Okay, we're going to review PEMDAS, right, which is our order of operations. That's how we manipulate our equations. So remember, that's please excuse my dear Aunt Sally, and that shows us what order we simplify when we're simplifying equations. So we got parentheses, exponents, then we multiply and divide. Okay, remember multiplying and dividing are really on the same level. You do it left to right, whichever one comes first. And then we have adding and subtraction, or subtracting, right? So they're on the same level too. So remember multiplying and dividing, you read left to right, whichever one comes first, and same with adding and subtracting. All right, so we got this example here, 6 squared minus 3 times 3 squared times 2 plus 5. Okay, so I do have parentheses, so this is what I'm going to start with, my parentheses here, right? But inside parentheses, I have some more operations. We have to use PEMDAS inside, right? So I have 3 to the second power, so there's an exponent, and then I have that times 2. So we got exponents and multiplication. Exponents come first. I'm going to do 3 squared. So that's going to end up giving me 9 times 2 inside my parentheses. And then I'm going to do 9 times 2. So I'm going to get 18. I'm going to bring everything else down. So I got the 3 out front, the minus, and the 6 to the second, and then a plus 5. All right, so that takes care of my parentheses. But I do have some more exponents here. So I'm going to go ahead and do my 6 squared, which is 6 times 6, or 36. All right, that takes care of E. All right, and then I do have some multiplying. Remember, if you have a number out in front of parentheses, that means that you're multiplying. So this is 3 times 18, or really it's a negative 3 times 18. So that's going to give me a negative 54 plus 5. So that takes care of multiplying. I don't have any dividing, so that one's good. So then I'm going to do adding and subtracting, whichever one comes first, left to right. So first, we've actually got the 36 minus 54. And that's going to give me a negative 18. And then bring down my plus 5, so that was my subtraction. And then negative 18 plus 5 is negative 13. Okay, if you struggle with your negatives when you're adding and subtracting and you're involving negative numbers, sometimes it helps if you think about being on an elevator where your ground floor, right, the ground is 0. And then you got your first floor, second floor, third floor as you go up. And then if you were to go below the ground, you could say that's your negative 1, negative 2, negative 3, right? So like, here's it's kind of like a vertical number line. So here's my 0, first floor, second floor, third floor, and then negatives on the bottom, right? So then that way, whatever number you start at, so like this one, I'm starting at the negative 18th floor, so I'm way down low at negative 18, and I'm adding, so I'm going to go up 5 floors. So if I'm at negative 18 and I go up 5 floors, I'm going to be at negative 13, right? So it might help, might not. It's just another way of looking at it. Okay, the other thing we're going to review is like terms. So like terms are terms that have the same base and same exponent. My whole clipboard's moving. Same base and same exponent. Right, so the base is kind of like your variable or your number or something, and then your exponent is obviously the exponent. So for example, if I had x plus 3x, I can combine those because they are like terms, because it is an x and an x to the first power to the first power. The numbers out in front don't really matter, right? And like terms, all I'm looking at is my variable. So these have the same variable, so that means I have 1x plus 3 x's, so I have 4 x's altogether. All right, same thing if I had, 2x squared minus 5x squared. Both of these are x to the second power, so I can combine those. So I have 2, and I'm subtracting 5, so that's going to give me a negative 3x squared. But if I had 2x squared plus 3x, I can't combine those because this one's x squared, this one's x to the first power. So those are not like terms. So you can only combine like terms, and that's going to come in play a little bit because we're going to have multiple x terms in the equation. Okay, so solving linear equations. We're trying to get the x by itself. I want to know what that x has to equal in order for my equation to work. So for the first one, I'm looking for what value of x that I can add 7 to and equal 2. Right? So you might can do that in your head, right? But sometimes they're going to be a little bit harder. So to do this, you're actually going to do the opposite of PEMDAS, right? So I'm going to start with any adding and subtracting. Then I'm going to do multiplying and dividing. And then I'm going to work on exponents and parentheses, right? So for this one, I have adding and subtracting here, okay? And that the opposite of PEMDAS kind of comes in when you have multiple steps. But I'm going to take care of this plus 7. Right, so to get rid of that plus 7, I don't actually just want to take it out because that's going to change my equation. I just want to move it to the other side of the equal sign, because if I move it over, I'm going to be left with x equals something. So to move it, I'm going to use the opposite operation. So this is plus 7, so that means I'm going to subtract 7. And whatever I do to one side, I have to do to the other. Right, and that's going to cancel it out over there, so that I'm left with just an x and then my equal sign, and then 2 minus 7 is a -5. So x equals -5. Now, the best part about solving equations is that I can check my work. I can see if I'm correct. And I can do that by plugging it back into my original equation. So I'm going to take this -5 and plug it in here. So if I do that, I have a -5 plus 7, right? And then -5 plus 7 is, in fact, 2. So that's how I know that I got the right answer. So you can always check your work. Right? For number 2, I have x minus 4. So to get x by itself, I'm going to add 4 to both sides. 6 plus 4 gives me 10. Okay. Number 3, I have division, right? Anytime you have a fraction, you can think division. So this is x, this is negative, x divided by 5. Okay. The opposite of division is multiplication, but before I multiply, I have to pick where I'm going to put this negative, right? A negative can either go out in front, so I could have negative x over 5, right? Or it can go up top, so I can have negative x over 5. Or it can go on the bottom, and I can have x over -5. All of these are the same, right? Because I want to get x by itself, I'm going to move it to the bottom. Okay, so I'm going to say that this is x over -5, like this one is over here. All right, so then I have to get rid of a -5, and the opposite of division is multiplication. So I'm going to multiply both sides by a -5, and that's going to cancel out the -5s and give me x by itself. Well, 10 times -5 is a -50. Okay, with negatives, remember, if I have 2 positives, they're positive. If I have 2 negatives, they're positive. But if I have a negative times a positive, it's going to be a negative. Okay, so if they're the same, it's a positive. If there's one of each, it's negative. Right, and then number 4, I have 2 times x, and the opposite of multiplying is dividing. So I'm going to divide both sides by 2. So we get x equals 7. Okay, if I'm going too fast in these videos, I do talk fast, especially when I'm sitting here talking to myself. So don't hesitate to pause and kind of read what I wrote down and see if you can catch up. And then if you need to, you can rewind and watch it again. All right, number 5, right, looks a little different, okay? I do have this 3/4 out in front, so it's like 3/4 times x equals 2. Okay, so really I am going to divide by 3/4, but that's getting kind of ugly looking because I'm going to have all these fractions. I'm going to have a fraction inside of a fraction. So the shortcut is to multiply by the reciprocal, and the reciprocal is if you flip your fraction. So my reciprocal for 3/4 is 4/3. So I can multiply both sides by the reciprocal and save myself a lot of time, and it's going to cancel out. Like the 3's are going to cancel because they're on top and bottom, and same thing with the 4's, right? So that's one step, and I get my x by itself. Okay, again, there's other ways of doing it, all right, but that's a shortcut. Okay, now if I want to multiply fractions, right, this 2 I can think of as 2 over 1. Right? Anytime you have a number, you can rewrite it as a fraction with a 1 on the bottom because 2 divided by 1 is 2. Right? So then you multiply the tops, you multiply the bottoms. 2 times 4 is 8. 1 times 3 is 3. Make sure you can't simplify a fraction. I can't. 8 over 3 is as simple as it gets, so that's my answer. For number 6, here's where we have more than one step, right? Because I've got a 3 and a 2 in there on the same side. So this is a multi-step problem. This is where that opposite of PEMDAS comes in. So I'm going to start with any adding and subtracting. So that means my first step is to get rid of that 3, right? So I'm going to subtract 3 from both sides. Then I'm left with a 2x equals 4. Then I'm going to move into my multiplying and dividing. So I've got 2x, so to get rid of the 2, we divide. So I get x equals 2. Another way of looking at it, instead of doing opposite of PEMDAS, you start from the farthest away from x and work your way closer. Okay, now we're going to ignore the 7, right? So it's just the 2x plus 3 over there. So the farthest away from x on this side is the 3, then the 2. So I got rid of the 3 first, then the 2. Right, for number 7, farthest away from x on this side is that 3, right? And it looks a little weird because it's out in front, but this is a positive 3. The opposite of a positive is a negative, so that means I'm going to subtract 3 to move it to the other side. So then don't forget about your negative here. That stays with the 4x. So I have a negative 4x equals a negative 12. Then to get x by itself, we're going to divide by a negative 4. Okay, then I have a negative divided by negatives. Oops, going to be a positive. So 12 divided by 4 is 3. Okay, for number 8, looks a little different again because now I've got a 1 inside the parentheses, a 2, and a 3 to get rid of. So farthest away is my 3, so that's the first one I'm going to knock out. And I'm going to add 3 to both sides. So then I'm left with 2 times x plus 1 equals a 24. Now there's multiple ways of doing this. If you wanted to, you could go ahead and distribute and multiply that 2 to the inside of the parentheses, then continue to solve. Or sometimes in some equations it's going to be easier to do it this way. So I'm going to do it this way just so you can see it. I'm going to go ahead and get rid of that 2 from the beginning, right? Because technically, even though it looks like it's closest to the x, it's outside of the parentheses, and we save the parentheses for last because that was a first of PEMDAS and we're going backwards, right? So I'm going to go ahead and get rid of the 2. Let me make sure I can see, right? And it's 2 times the parentheses, so I'm going to divide. So we've got x plus 1 equals 12, and then now all I have to do is get rid of the 1, so we get x equals 11. Okay, a few more. All right, number 9, farthest away from my x is this 7. So I'm going to start by subtracting 7 from both sides. So 2x plus 5 over 3 equals a negative 9. All right, now this 3 is in the denominator of the fraction, the big fraction. So really this 3 is farthest away. So I'm going to start by getting rid of the 3. And remember, anytime you have a fraction, you can think division. So this is top divided by bottom. So this the 2x plus 5 divided by 3. The opposite of dividing is multiplying. So we're going to multiply both sides by 3. So I get 2x plus 5 equals a negative 27. And then I can subtract the 5 over. So we get 2x equals a negative 32. And then I can divide by 2. And x equals a negative 16. All right, for number 10. Here's where we go back to those like terms we talked about in the beginning, because I now have an x, a 3x on the left side, and a 2x on the right side of the equal sign, right? So before I can solve for x, I have to get down to just one term that has x in it, right? I have to get down to just having the 1x so that up here, like I was able to get that x by itself. If I have two x's out there, I can't get one of them by itself because then there's going to be another x in there. So I'm going to start by putting the x's on the same side. So I personally like to put my x's on the left. It does not matter which x you want to move. So I'm going to get rid of this 2x and I'm going to move it over to that side with the 3x. I'm going to combine them because they are like terms. So this is a positive 2x, so I'm going to subtract 2x from both sides to cancel it out. Right? And then I can combine these two because they're like terms. That 1 I can't put with it because the 1 and the 2x are not like terms. So I've got 3x minus 2x, which is just a 1x. And remember, if you have a 1 in front, you don't have to write it. Okay, a coefficient of 1 is not something you have to put there. You can, but you don't have to. And then I'm going to bring down this plus 1 equals, I'm going to bring down that minus 4. And now it looks like the other equations, a very quick -1 from both sides, so we get x equals -5. But if you have x's on both sides of your equal sign, you've got to get them on the same side so that you can solve. So for number 11, all right, I've got a -9x over here and a 6x over here. So I'm going to start by moving the 6x over to be with a -9x. So this is a positive 6x, so I'm going to subtract 6x. Right, that one cancels, and now I can combine these. So I have a -9 minus 6. So that's going to give me a -15x. And then I'm just going to bring down the 5, bring down the 2 and my equal sign, and then I'm going to solve. So I have a +5 out front, so I'm going to subtract it to move it. So I'm left with a -15 over here. Again, don't forget that negative. You got to keep it out in front. 2 minus 5 is a -3. And then I'm going to divide by that -15 to get x by itself. All right, so a negative over a negative cancels. But obviously 15 is way bigger than 3. So 15 doesn't go into 3, but I can simplify. 3 goes into both 3 and 15. So if I divide them both by 3, 3 divided by 3 is 1. 15 divided by 3 is 5. So all I did was simplify to get to my simplest fraction. Okay, so we're solving equations for x or for whatever variable. It means that you're trying to get that variable all by itself. We're isolating the variable using opposite operations. And if you have multiple variables or the same variable there multiple times, you got to get them all on the same side so you can combine them. Then do all of our steps for solving.